Hello everybody, I hope you're all doing well. This lecture is about inequalities. We have already studied equations. So solving inequalities will be somehow the same way of solving equations, especially the linear ones. It will be pretty much similar to each other. What is the difference between equations and inequalities? At the beginning, if you look at, for example, that linear equation for x plus 2, that's equal to 5, that one is an equal sign between them. So that one is called an equation. That means there is a balance between that side and this side. They are both the same. But when we are talking about inequalities, that means something is greater than something else, something is less than something else, or something is greater than or equal to something else, and so on. For example, if you have got 4x plus 2, it may be, if we are talking about inequalities, it is maybe less than or equal to 5. We have got 4x plus 2, it is maybe greater than or equal to 5. These ones are called inequalities. We have got the case if 4x plus 2 is less than 5, 4x plus 2 is greater than 5. So these symbols that we have got, those symbols that we have got represent inequalities. So instead of having an equal sign, we have got those symbols which represent inequalities. We have got linear inequalities and nonlinear inequalities. Linear inequalities are those kinds of inequalities that the greatest power of the x is equal to 1. The equation that we have got is of highest power of 1. Before going to solving inequalities, we say that we have got some properties for inequalities. When we are talking about equations, for example, this linear equation has got exactly one solution. For example, if you want to solve this one, 4x plus 2, that's equal to 5. If you want to solve it, of course, we are putting knowns on one side and unknowns on the other side. So that one will be 5 minus 2. And 4x is equal to 3. We divide both sides of the equation by 4 to find x. You already know these steps. So x is equal to 3 over 4. When we want to represent this number on the real number line, it is only 1 point. So it is, if you look at this one, it is 0 point something. So if you have got the real number line like that, it is somewhere here, 3 over 4. Okay, 3 over 4 is somewhere here. So that point is the only solution for that equation. But if we want to solve an inequality, we have got, most of the times, we have got infinitely many solutions for that inequality that we have got. For example, if we choose to solve this one for x plus 2, that's less than or equal to 5, we get the result as this one, okay? But we have got the case it is less than or equal to 3 over 4. What does that mean? That means my solution is all that numbers that are less than or equal to 3 over 4. So 0 can be a solution, minus 1 can be a solution, minus half can be a solution, any other number that is less than this one can be a solution for the given inequality that we have got. If you want to represent it on the real number line, it will be represented as this way. Again, we have got the real number line. If here is 3 over 4, here is 3 over 4, our solution, and all those numbers that are less than that number. So it includes all those numbers and keeps going on till negative infinity. So these ones in equations, we have got only, when we have got a linear equation, we have got only one solution. One x holds for this one, but when we are talking about inequalities, we may have infinitely many numbers that would be a solution for that inequality. Let's go through the rules of inequalities, the properties of inequalities. The first rule that we have got is that if we have, let me write the rules or properties of inequalities. The first one is that if I have got two numbers or two expressions that is less than the other one, A is less than or equal to B, that will be okay. That will be fine if we add the same quantity to both of the sides. That means if I have got a C, a number C, a term C, if I add that C to both of the sides, the inequality will still hold the same. If you look at here, I added C, any term, any an equal term, of course, adding the same quantity to both of the sides of that inequality, this one will still remain the same and not change sign. For example, if you have got a kilo of potato that's less than 2 kilos of orange, if you add 1 kilo of apples on both sides, apples, look, I'm adding the same quantity, adding the same amount, 1 kilo of apples to both of the sides of the scale, this side will still be less than the other side, so we are adding the same quantity. That one is also true when we are subtracting the same quantity from both of the sides. So if I have got A is less than B, less than or equal to B, if I subtract the same quantity, okay, this one is the same quantity from both of the sides, the inequality will still remain the same. Okay, I'm subtracting the same quantity from both of the sides, so this one will not change. It will still be less than the other one. The third rule says if C is greater than 0, that means C is a quantity that is positive. If I multiply it with A, okay, and B, the inequality will still be the same. So that C is positive. It's a positive number. For example, like 1, 2, 3, 1.5, these ones are all positive numbers, positive quantity. If I multiply it with A and B, okay, then that inequality still holds. Why? Because A is already less than or equal to B. If I have got A is less than or equal to B, so if I multiply that positive C to both of the sides, so it will still remain the same. The fourth inequality, the fourth rule is what? The fourth rule, it says if C is less than 0, okay, less than 0, and if A is less than or equal to B, then what do I get? Then I will get CA is greater than or equal to CB. Okay, so if that C is a negative number, -2, -1/2, negative any number, and if that quantity is less than this one, if I multiply that negative number C to both of the sides of the inequality, it will change, it will reverse the inequality that I have got. If it is less than or equal to, it will change to greater than or equal to, and if this inequality is greater than or equal to, this one will be less than or equal to. So it reverses the inequality when you are multiplying an inequality by a negative number. Okay, the fifth rule, what does it say? It says if A is greater than 0, so I have got a quantity that is positive, and I have got another quantity that's also positive, A and B. Then if A is less than or equal to B, their reciprocal will reverse the inequality. So I will have 1 over A will be greater than or equal to 1 over B. Okay, for example, if I have got A and B are greater than 0, if I have got, for example, 2 is less than or equal to 3, okay, 2 is the A and 3 is the B. Both of them are positives. I have got a condition here, both of them are positive. So what will I get? What is true for that? The thing that is true, if I take their reciprocals, 1 over 2 will be greater than or equal to 1 over 3, and that is a fact. You already know that 1 over 2 is greater than or equal to 1 over 3. So here is the condition. These ones are positive numbers. A is less than B. So I must have 1 over A greater than or equal to 1 over B. The sixth condition, it says if A is less than or equal to B, so I have got something less than the other thing, and C is less than or equal to D, I have got two other things with an inequality between them, then I will have for sure that A plus C is less than or equal to B plus D. Okay, so this one is less than this one, that C is less than that D. If I add this with that, okay, this one with that one, if I add them, will definitely be less than this one plus that one, b plus that d over here. Okay, of course these two quantities are great, so if you add them it will definitely be greater than those two small quantities that we have got. These are the rules, the basic, the simple rules of inequalities that we can apply them while solving the inequalities that would be given to us. Now we are coming to solving linear inequalities. Solving linear inequalities is pretty much the same as solving equations, linear equations. So we have got solving linear inequalities. What is the linear inequality? Of course, we have got in example 1, we have got an inequality that's given to us 3x less than 9x plus 4. We said when we are talking about linear inequalities or equations, we have got the greatest power in the expression is 1. If you look at here, we have got the power of x's are equal to 1. For solving linear inequalities, the same way that we were solving equations, we are putting knowns on one side and unknowns to the other side. So what do we have? We have got 3x here and 9x here. Both of them have got unknowns in it, and the 4 over there is alone. So either I'm saying I'm taking that 9 to the other side with the opposite sign, or I will say I'll subtract minus 9x from both sides of that inequality. Okay, so you can say either I'm taking that 9x to the other side to put the x's together and the numbers together, or I can say I'm subtracting minus 9x from both sides of this inequality. So how will this one change? That inequality, it will be 3x minus 9x is less than 4. I just took this one to the other side, so 9x minus 9x. Now 3x minus 9x is equal to minus 6x, okay? It's less than 4. We're searching for x. Since we are searching for x, we are dividing both sides of that inequality by minus 6. When we are dividing it by minus 6, here in rule 4, we said if we have got a negative number, and if it is multiplied to both sides of the inequality, of course, we have got multiplication and division, they are inverse operations. So when we say we are multiplying it, that means the rule is also true for division. Okay, since we are, or here you can say it in another way. Instead of saying dividing, you say I'm multiplying both sides of the inequality by minus 1 over 6. Okay, so look, either you are saying I'm multiplying it by negative 1 over 6, or you say I divide both sides by negative 6. So it gives the same idea, and rule 4 holds. When we are multiplying it by a negative number, the inequality was reverses from less than or equal to becomes greater than or equal to. So that 6 cancels that 6. So x becomes greater than what? X becomes greater than 4 over minus 6. 4 over minus 6 is divisible by 2. 4 divided by 2 is equal to what? I will divide both numerator and denominator by 2. So 4 divided by 2 is equal to 2, and 6 divided by 2 is equal to 3. So that one is the solution for that inequality that we have got. If you want to represent this one on the real number line, of course, I will ask you to, you will be asked to draw it on a real number line, to draw the solution on the real number line. It will be easy for you because you're already familiar with those steps. Here is the real number line that we have got. Here are the numbers. Here we have got 1, it keeps going on. We have got 0, we have got here we have got negative 1, and so on, it goes to there. Negative 2 over 3, it is negative 0 point something, okay? It's around here. That is the number that we have got, 0 point, that is minus 2 over 3. That's the number we have got for the solution. And then it includes all those numbers that are greater than 2 over 3. Which numbers are greater than negative 2 over 3? Of course, this part, okay? This part is the line, is the solution for the inequality that we have got. How about this inequality sign? When we have got no equal sign with the inequality, we make a hole on the number that we have got. So here we have got what? We have got greater than minus 2 over 3, so I will leave that hole open because negative 2 over 3 is not a solution for this one. The numbers that are greater than negative 2 over 3 become a solution for that inequality. As we said, what does it mean when we say it is a solution for that inequality? That means whichever number I'm choosing from that part, for example, I choose 1, when I put it in that inequality, it must be satisfied. That means 3 multiplied to 1 must definitely be smaller than, be less than 9 multiplied to 1 plus 4. So any other number that you're choosing from that side must satisfy that inequality that we have got. So what is the solution for this one? If you want to write it as an interval, because we've already studied how to represent numbers as intervals, that will be minus 2 over 3 to infinity. I have got the number starts from minus 2 over 3 with an open interval because minus 2 over 3 is not in the solution, and it keeps going on to infinity, so it will be till infinity. Now in example 2, that was example 1, we have got solving a pair of simultaneous inequalities. What is simultaneous inequalities? Simultaneous when you have got two equations, two or more inequalities that are given together and to be solved together. So here we have got in example 2, it says solve the inequality for less than or equal to 3x minus 2, and that one is less than 13. That is the simultaneous inequality. Why is it called simultaneous? When you look at it, you can see only one inequality. I mean, one expression, not one inequality. But in general, in real, it is what? It is two inequalities. One part of the inequality is this one. Okay, this is one part of the inequality, and that one is the second part of the inequality. That's why it's called simultaneous, because here two inequalities are combined together to form one statement of inequality and to be solved. How do we solve these kinds of inequalities? Either we are separating the red part, solving it here alone, and then the green part, solving it here alone, or we can do it in such kinds of simple inequalities. We can solve it together. The simultaneous equation, we can solve it together. How can we solve it? Of course, we are searching for x, and x is present here, not here, not there. So we have to leave that x alone to find the solution. To leave that x alone, we have to get rid of that negative 2, and we have to get rid of that 3. First, we will get rid of that 2. So I will add 2 to all of the 3 parts of the equation, of the inequality, sorry. Okay, that part plus 2, that 13 plus 2, and that 4 plus 2. Of course, I said you're adding the same quantity to all of the sides of the inequality. You cannot add 2 here and not doing it on those sides. The inequality, the imbalancing will change. So you have to add the same thing to all of the sides. Now, 4 plus 2 is equal to what? 4 plus 2 is equal to 6. The inequality symbol doesn't change. 3x minus 2 plus 2 is equal to what? These two ones cancel each other because minus 2 plus 2 is equal to 0. So 3x remains in the middle. The inequality doesn't change. 13 plus 2 is equal to 15. Now still we have got something left with the x. So we are dividing the 3 sides of the inequality by 3 to get rid of that 3. So that 3 cancels that one. Okay, that one cancels this. What is remained here? X is remained in the middle alone. This side, 15 divided by 3 is equal to 5, and 6 divided by 3 is equal to 2. So what is the solution for that inequality? It is equal to those numbers that lie between 2 and 5. If you want to represent it on the real number line, let's sketch it. if here is 0, okay, here is -1, for example, here 1, 2, 3, 4, 5, 6, and keeps going on. What do we need to do? What are the solutions for that inequality? The x, the numbers that I have got are between 2 and 5. So I will, and since I do not have equal signs here, so I will leave the 2 open. Okay, I will not fill it up, and I will leave 5 open. Oh, sorry, here I have forgotten this symbol. I have got equal sign here. So since I have got equal sign with the 2, sorry for that, I forgot to write this one down. Since here the equal sign is with the inequality, so I will fill up the 2 that I have got, and I will leave the 5 open because it doesn't have equal sign with it. And of course, it includes all those numbers that are in between them. So this part is what is the number of solutions for that inequality. Again, what does it mean when we say it is a solution for that inequality? That means whichever number I'm choosing from this red part, if I put it instead of the x, it must definitely satisfy the inequality that I have got. So that one is what? So far what we have studied. We have studied inequalities, what are the inequalities, properties of inequalities, and solving linear inequalities. Either we have got one simple expression or we have got simultaneous inequalities given to us together. Now we are coming to solving nonlinear inequalities. How do we solve nonlinear inequalities? Or let's say, what are nonlinear inequalities? You have already studied nonlinear equations. Nonlinear inequalities are those inequalities where the power of x is not equal to 1. It is either greater than 1, or we have got other kinds of functions included in the inequality. So in general, the inequalities that you have got are not of this kind. The power of x that we have got is greater than 1. So we have got solving nonlinear inequalities. How do you solve these nonlinear inequalities? If we are given x squared, the first example for nonlinear inequalities, itself says solve the quadratic inequality. So we have got x squared is less than or equal to 5x minus 6. How can we solve that nonlinear inequality? And why is it a nonlinear inequality? Because we have got the greatest power is 2. It's a quadratic inequality. It's not linear. So for solving these kinds of inequalities, we are solving it by factorizing them and by finding the signs for the inequality that we have got. So here, for solving this one, I'm putting everything to one side and leave 0 on the other side. So here we will have x squared minus 5x plus 6 is less than or equal to 0. So the first step you're doing for solving those kinds of quadratic inequalities, you're putting everything else on one side and 0 on the other side of the inequality. And you know that when you're moving these ones to the other side, it will change sign. This one is positive 5x becomes negative 5, and that one is positive 6. Now we have to factorize this one. We have already studied how to factorize quadratic equations. So since I have got a quadratic inequality, this one changed to 2 brackets, 1x here, 1x over there. For getting 6 and 5, either it is 6 by 1 or we have got 2 multiplied to 3. Okay, so I'm choosing 2 and 3 because these ones are the correct ones. Both of them with negative sign. When I multiply them, I'll get positive 6, and when I add them, I get negative 5. Now, what's the next step to be done? To find the solution for such kinds of inequalities, it's better to draw the real number line and write the factors on that real number line with checking their signs. Okay, here is the real number line. And I will look over here. What number makes this part equal to 0? If I put 2 here, it will make this part equal to 0. So 2, the factor of this one is 2. and the factor for that one is 3. Why am I saying 2 and 3? Because 2 makes this part equal to 0 and 3 makes this part equal to 0. So I'm putting that 2 and 3 on the real number line, okay? Of course, ordering. Here is 2 and here is 3. I'm just putting those numbers, those factors that makes that parenthesis equal to 0. So 2 makes this one equal to 0, so I put 2 here. This one, 3 makes it into 0, so I'll put 3 here. I'll choose test numbers. What are test numbers? Test numbers are those numbers that I'm choosing from each interval. When you see 2 and 3 on the real number line, it separates the real number line into 3 different intervals. One interval is from negative infinity to 2. Another interval is between 2 and 3. The other interval is between 3 and infinity. So from each interval, I will choose a test number. That means a number from each interval. Any number that is less than 2, always choose the easiest number. For example, choose 0, okay? Here, choose 0 as a test number. You can also choose 1, you can choose -1, -2, but the easiest one to deal with is 0. So I will choose 0 here. Between 2 and 3, choose 2.5. That one is the easiest number, or any other number, 2.1, 2.9. These ones are all fine, but we are choosing the simplest one. And a number that is greater than 3, we will choose 4. Okay? So these numbers that I choose as a representative for each interval, these ones I will call them test numbers. Then what will I do? I'll put those test numbers into that interval that I have got, or let me say into the inequality that I have got, not interval. How do I put it? Let me write them for you. Here I have got -2 and -3. If I put 0 instead of the x that I have got, it will be 0 minus 2, okay? 0 minus 2, 0 minus 3. If you look at this one, do I get a positive number or a negative number? 0 minus 2 is -2. 0 minus 3 is -3. -3 multiplied to -6, I will get a positive 6, okay? -3 multiplied to -2, I get positive 6. But I don't care about the result. I just care about the sign, whether it is positive or negative, okay? So I'm writing that this one is positive, okay? When I choose here, okay, any number that you choose from here and you put it here, you will definitely get a positive number. Now we are testing 2.5, okay? I put 2.5 here. Again, I don't care about the result. I care about the sign, whether it is positive or negative. 2/2 minus 2 is a positive number, and 2/2 minus 3 is a negative number. This one is negative, I get a negative result, and that one I get a positive result. Negative multiplied to positive is a negative number. So any number that you choose in between here, you will get a negative number. Okay, so what did we say? Here I get a negative result. This one is a negative result. Negative multiplied to negative becomes positive. From this one I get positive. From 2/2 minus 3 I get negative. Positive multiplied to negative, I get a negative number. Now let's test 4. 4 minus 2 and 4 minus 3. What do I get? 4 minus 2 is a positive number. Okay, as I told you, I do not care about the result, what number I get. I only care about the sign, positive or negative. 4 minus 3 is equal to what? I mean, what sign do I have? I have got a positive number. So positive multiplied to positive, I get a positive number. So here is also positive. Now, from this procedure that we did, what did we get and why did we do that? Here I say the inequality that I have got, okay, the inequality that I have got is less than or equal to 0. That means it is a negative number. Here, when we tested those ones in each interval, which part did I get a negative number? That part, I got a negative number, okay? So this part will be a solution for that inequality. Look here, I say my inequality is less than or equal to 0. That means the numbers that I get in here are negative numbers. And when we tested those numbers from each interval, the only negative sign I got is from that interval. So that interval will be what? Will be the solution for that inequality. So what is the solution for this one? It will be 2 and 3. Those numbers that lie between 2 and 3. This is a closed interval of 2 and 3. Why did I make that interval closed? Because here I have got equal sign with the 0. If there was no that equal sign, this interval would have been open. So this is the way of solving nonlinear equations. We have got also other nonlinear equations. We will keep going on solving those equations in other lectures.